All right, hello guys. Sorry I couldn't be there today. This is going to be kind of a longer video, so please feel free to pause and stop if you need to. Also, you have guided notes that the sub should have given you, so please use those. That'll really help with your note taking. However, there are some things that are not in the guided notes, so you might want an extra sheet of paper out if you want to take extra notes on those. There's a few little things. So for example, vocabulary, some things I need you to know, and we've talked about theorems before, but a theorem is a true statement that follows as a result of other true statements. And these are things that have been proven. The mathematicians before us have proven these theorems, and we will be coming across these theorems in subsequent sections. So please make sure you understand that theorems have been proven already. All right, we talked about a two-column proof last time when we did an algebra proof, and it's just when we write numbered statements and reasons to show our logical order of the argument. But I want to introduce you to two other kinds of proofs. We have a paragraph proof, and basically you just write out in sentences what your statements and reasons are. It's more like an English type of argument. And then we also have something called a flow proof. And these look more like flow charts. So it'll have a lot of like bubbles with arrows and things like that. And I'll do an example for you in just a little bit so you can see what that looks like. I'll also do a paragraph proof so you can see what that looks like as well. All right, so some three new properties that I need you to know, and you want to write this down either on your guided notes or on a separate sheet of paper. These are properties of segment congruence. Let me move that so you can see. All right, so remember we had the reflexive property of equality. Well, now we have the reflexive property of congruence. So if I have a segment AB, then I know AB is congruent to AB, the segment. And then the symmetric property also works for congruence. If I have AB as congruent to CD, then I know CD is congruent to AB. Notice the difference here is that I'm using congruent symbols, and I'm using the line above the segment to show that it's the shape itself. And then the transitive property, notice that if I have AB is congruent to CD and CD is congruent to EF, then I know AB is congruent to EF. So we'll be using some of those today because it'll actually make some of our proofs shorter. Sometimes they won't, but you'll see when we get there. So as I said before, we have three different kinds of proofs. So the kind we did with algebra was that two-column proof, and that looked like this. Here, let me move this back up. So it looked like with the statements and the reasons and all that stuff. And I said there's another kind that's a paragraph proof, so that looks like this. Notice there's a lot of words. You just explain your logic. And then there's going to be flow proofs. So a lot of these will have statements with reasons and arrows going to the order. So you just follow the arrows to follow the logic. So you have this example on your sheet. So we're going to do this one as a flow proof so you can see how that works. Okay, so when we read this information, it says solve for the variable. So we know we're going to be done with the proof when we have x equals something. And notice what we are given. We're given DE is congruent to EF. So I'm going to mark that in the diagram. DE is congruent to EF. And then it also says EF is congruent to GF. So I'm also going to mark that congruent. All right, so when we do our proof, we will have to show that these two segments that have labels on them with x's, we'll need to show that those are congruent to each other. And then we'll need to then set up an equation so that I can write 3x minus 5 equals 7x minus 21 and then solve. So here's how a flow proof starts. You're just going to write, just like we would with our given, we would write our given information. DE is congruent to EF, and EF is congruent to GF. And then what you do is you draw a line underneath your statement, and then underneath that you give your reason. So this is given. And then we'll put a big circle around that. And then I'm going to put an arrow toward the next bubble. So from there, I'm going to use our new property of transitive property of congruence, and I'm going to say DE is congruent to GF. I know that because, as you can see, the EF is what's repeated, so DE and GF are going to be congruent to each other. So that's because of the transitive property of congruence. So POC this time, not POE. All right, put a circle around that. Now I'm going to change these into equal signs because I won't be able to work with the variables without having the equal signs. So this is kind of a new thing. You've probably not seen this before. So you might want to put a star by this so you remember what to do when you need to go back and forth between congruents. So if I need to go from congruent symbols and having shapes congruent to their length being equal, then all we use is the definition, DEF for short, of congruence. And you can use the congruent symbol. Because that's what congruence means, is that their lengths are equal to each other. So I'm just changing from congruent to equals there in that step. All right, now, I also know from my diagram that DE is equal to 3x minus 5, and I also know that GF is equal to 7x minus 21. So I'm going to say that that was given, even though it was not listed, it was given in our diagram. Okay, so I'm going to use this red circle and this black circle together. We're going to create a new equation. So I'm going to put arrows coming off of both of those, and I'm going to show that 3x minus 5 equals 7x minus 21. So how do I know that? All I did was substitute those values into this equation right here. Into DE equals GF, I just replaced. So we're going to say that that's substitution property. And this is POE because we're using equal signs. Notice that there is no substitution property of congruence, so don't ever put POC for substitution. Okay, so from here, this is just an algebraic proof. We're just going to solve this. So I know from here I'm going to subtract that 3x on both sides. So that's going to give me negative 5 equals 4x minus 21. So that's subtraction property. All right. And I don't know if this bothers some of you because now I'm going from right to left. So sometimes that's what kind of bothers me about flow proofs. So I understand if that's kind of bugging you, but I'm only going to do one today, and you decide if you're totally okay with that. If that follows your preferences, then you go for that. But I'm just showing you as an option. And then from here, I know that I'm going to add that 21 to the other side, so that's going to leave me with 6 equals 4x. So that was the addition property. And then from there, we can divide both sides by that 4. So that's going to give me 3/2 is equal to x, using the division property. All right, so there's a flow proof for you. So let's move on. If you need more time to copy that down, please pause. I'm going to move on. For this next one that you have on your sheet, we're going to do a paragraph proof. All right, so notice again, we're trying to solve for the variable, and we're explaining our steps, and we're given that EG is congruent to HF. So EG goes from here to here, and HF goes from here to here. And we are given that those are congruent, so I'm going to mark those congruent. Okay, so in my paragraph proof, I'm just going to write in sentences as I do my thought process. So my first thing I noticed, again, I want to be able to set up an equation. So I'm going to say, change this from congruence to equals. So I'm going to say if EG is congruent to HF, well then I know EG is equal to HF by the definition of congruence. I'm going to abbreviate here. Okay. Also, in order to be able to write an equation, these segments that they gave me are made up of two smaller segments. So this is like what we talked about last class. I'm going to say EG is equal to EF plus FG. And I'm going to do the other one while I'm at it. And I know that HF is equal to FG plus GH. And those are both by the segment addition postulate. So from there, what can we say? Well, we can substitute. So I'm going to replace EG and HF with their equivalencies. So instead of EG, I'm going to write EF plus FG is equal to, and then instead of HF, I'm going to write FG plus GH. And I know that by using substitution. Then notice that what I have on both sides is FG. That's that common segment in the middle. So I have this and this is common. So I'm going to say EF is equal to GH, by the subtraction property. Okay. Now we have an equation. So I'm going to say now, using the diagram, so that's like using the given information. In substitution, I know that 4x equals x plus 9. So now that I have an equation, I can say 3x is equal to 9 because I subtracted that x on both sides by subtraction. And then I can say x equals 3 by the division property. There we go. We've got our paragraph proof. So it's really, we're doing the same thing, we're just writing it in sentences. Some of you may love this, it gives you more freedom, but some of you might hate this because it's a lot more writing. So again, I'm just showing you options so you know that there's other things out there besides two-column proofs. All right, but as I said before, my brain kind of goes toward the more structured part, so I like the two-column proofs. All right, so let's do a two-column proof. This is a fill-in-the-blank kind of proof. So we're going to try to figure out, someone has worked out part of this, and we're going to try to follow their logic. So let's look at this diagram together first. So given AD is 8, so this segment is 8, and BC is 8. And then they say BC is congruent to CD. So we're trying to prove that AD is congruent to CD. All right. And think about that. Do we think that's true? Well, if these are both 8, right, then those are congruent to each other. And then BC and DC are both congruent. So yeah, these are going to be actually congruent, and I could change my symbols to be just single tick marks right here. So I believe that that is true. So let's try to fill in the blanks here. These are options, okay? So we are going to be filling that into the proof there. You have that in on your sheet. I just wanted you to know what those were. Okay, so number 1 says given. So let's look at the things that are given. And the only thing that's in our list that has not been given yet is AD is equal to 8. Okay. And so they're telling us they're using those two givens, and then they say to use the transitive property of equality. Well, notice that 8 and 8 is what's repeated, so we should be looking for something that says AD equals BC. Okay, and we have that here in A. Now notice that it's not AD as congruence. We only have equality here. We don't have congruence. Okay. Now on the next line down it says definition of congruence, so that should look exactly like number 3, except it's going to have congruent symbol. All right, so that would be this one. All right, and then it says BC is congruent to CD. Well, that was something they told us from the very beginning, so that was one of our givens. So I'm going to put that in the given. All right, and then what did they do here? They said AD is congruent to CD. Now notice that we have now in 2 different statements we have repeated BC, so that's what they're using there. So we're going to be using the transitive property of congruence this time, all right, since we have congruent symbols. So there you go, there's our proof. So on the next proof, see if you can fill that in. So pause the video right now and see if you can fill that in without my help, and then I will show you what that looks like when you're done. All right, so this statement was given, and then they used the transitive property of congruence again, and then this one was given. So I hope this one was pretty easy to fill in. Both of those missing statements were given, and they just did a whole lot of transitive properties. If this is congruent to this, then this is congruent to that. All right, so moving on to in your guided notes, we have in this diagram, they are giving us, ooh, let me move this over a little bit. They have AC is equal to CE. So let's draw that. So AC is congruent to CE, or not congruent, equals CE. All right, so I know that those two lengths are equal. And they also say that AB is equal to DE. So AB is equal to DE. All right, and we're trying to show that C is the midpoint of BD. Well, first, do you think that C is the midpoint of BD? So in other words, we're trying to figure out, is BC the same length as CD? Okay, that's what we're trying to show. If we can show that those two segments have the same length, then we can show that C is the midpoint. Okay? So they have it written here. So they say these are our givens, and we have to prove C is the midpoint. So first things first, given. And then now they're saying AB plus BC equals AC. Well, that wasn't one of our givens, but that is something that we've talked about before. That's showing that green line is made up of those two smaller segments, so that must mean segment addition postulate. Okay. Now we are moving on. Now I have to fill in a statement. It says transitive property of equality. So there must be something that's repeated in these two statements we just did. So look for the repeated part. Yeah, the AC. So then we should be able to say then AB plus BC is equal to CE. That's the transitive property. All right, so we have another new equation with two things added together. And again, if you check back in the diagram, that's this second green segment that is made up of the two smaller segments. So this would also be segment addition postulate. And then they want us to use transitive property again. Okay, so If you look here, what's repeated? The CEs are repeated. So my new statement should be, CD, I have it already. AB plus BC is equal to CD plus DE. All right, so that's using the transitive property. So now look what they did. They said AB equals DE. Why would AB equal DE? Oh, well, that's given, isn't it? So don't forget to go back and look. And sometimes if you have trouble splitting up the givens, you can write them all at once at the beginning, if that's more helpful. But sometimes it's more helpful to split them up so you can see them and they're more immediate. All right, so now look at what we have. We have AB plus BC, that's exactly like number 5. And then we have CD plus AB. So they replace DE with the AB. Do you see that? That's what got replaced there. So if we replace anything, that's called substitution. And now they want us to do a subtraction property. Well, if we do subtraction, there must be something that's the same. So we're actually subtracting this AB from both sides. So if we do that, then that would look like BC is equal to CD. Hey, isn't that what we were trying to show, right? We were trying to show that those two segments were the same length. Well, now they want us to use the definition of congruent segments. So we're going to switch from equals to congruent. Okay. And now here's a new reason that we haven't talked about yet. C is now, we can say now that C is the midpoint of BD. Anytime the reason is, well, that's because that's what it means, that's always the definition. So we're going to put this is the definition of midpoint. So anytime you come across a reason that you're trying to figure out and you're trying to say to yourself, well, that's just what that word means. Okay, that means definition of whatever that word is. All right, so now that I've done that, try to do this checkpoint problem by yourself. It's very similar to the one we just did. So pause the video and do this one yourself. Okay, so here's what your fill-in-the-blank proof should look like. I'll scroll down just a little bit so you can see more of the statements and reasons. And if you have any questions as you're going along through this, make a note of that. That way you can ask me that next class. Because it's okay to have questions. And sometimes your classmates might be able to answer it. So maybe if you ask your partner or anyone in your group, they might be able to help you too if you're not understanding something. All right, so let's move on. You've got 2 proofs down at the bottom there, and I'm going to allow you to do those problems on your own, and you can do what, for the first one, you can do it in any format you want. So you can do a 2-column proof, you can do a flow proof, you can do a paragraph proof. When I show you the answers, I'm going to write mine as a 2-column proof. On that second one, that's not really asking you to write a proof, it's just asking you to solve what that should be. And again, that's just to get you back in that frame of mind of how do I think about geometry problems. All right, so again, I'm pause the video and try to do that proof on the lower left-hand side. Okay, so just like before, make sure you mark your diagram so that you know what you're going for. Remember that because you knew that x is the midpoint, your next statement should then be mx is congruent to xn, because that's the definition. That's what allowed you to mark that diagram that way. And then make sure to change to equal sign because we're trying to prove that xn equals rx. So you want to make that transition, so I did that here. And then you're also given an equal sign, so mx equals rx, so that's where I chose to use that there. And then you can see the repeat right here and here to use the transitive property. And make sure you use transitive property of equality, not of congruence. So how'd you do on that one? All right, then let's look at this one. This one, since AB is congruent to BC, and BC is congruent to CD. Then we know by transitive property that AB is congruent to CD. So 3x minus 1 is going to be equal to 2x plus 3. So if we solve that, I'm going to subtract the 2x, and now I'm going to add the 1, and so I get x equals 4. Notice that they didn't want us to find x, they wanted to find BC. Well, BC is going to be the same length as any of the other two. So if I plug this 4 back into one of those, I'm just going to choose this one. So I'm going to get that this is 11. So BC is equal to 11. Okay, so that should help you get your thought process flowing. All right, so now we're going to switch over to angles, and notice that we have the same congruence properties for angles as we do for segments. So again, you can just use reflexive property POC, symmetric POC, transitive POC, and that works for angles as well. Okay, so let's do the first one actually on your sheet. So it says, let me move that. In the diagram, 1 is congruent to 5, so I'm going to mark those congruent, and 5 is congruent to 3, and then it says the measure of angle 1 is equal to 103, so what is the measure of angle 3? Well, if we explain our reasoning, just to give you some idea, we know that angle 1 would be congruent to angle 3 by the transitive property of congruence, right? That's the new one. And then I would switch again to be equal. So I would say the measure of angle 1 equals the measure of angle 3. And remember, that's the definition of congruence. And then I can now substitute 103 for the measure of angle 1. And now I know for sure that the measure of angle 3 is equal to 103 by substitution. And notice that's POE, since we're in equal signs. So we're going to use that kind of idea to do some formal proofs. All right, so here's another fill-in-the-blank proof. We know in this diagram we're trying to prove that angle 1 is congruent to angle 4. And look at what we're given. Angle 2 the measure of angle 2 equals the measure of angle 3. And the measure of AXD, so you might want to trace that out, AXD, and I like to mark it in my diagram, that way I know for sure what's going on. That one is equal to AXC, so that's that one, okay, that big one. So if we're trying to prove 1 and 4, notice that 1 and 4 are both parts of those bigger angles, and then we have 2 and 3 are congruent parts of those smaller angles. So we're probably going to be subtracting those congruent parts somewhere if I had to guess. All right, so first thing they gave us is the given. And even though we didn't do this last class, we know that we can do angle addition postulate as well. We can add up 2 smaller angles to equal a bigger angle, and that's called the angle addition postulate. So if we look at AXD, that's the red one, that's made up of angle 1 and angle 2. And then if I do that again for the green one, AXC, then I know that that's made up of the measure of angle 3 plus the measure of angle 4. So anytime you're adding up 2 smaller angles to equal the bigger one, that's angle addition postulate. So again, that might be one that you star and make sure you're using flashcards or Quizlet on. So now what's going on here? They're doing that substitution, right? We're replacing 1 plus 2 in for AXD and 3 and 4 for AXC. So that's just substitution property. And notice that we're working with equal signs. All right, and then they're saying measure of angle 2 equals the measure of angle 3. That was given. We knew that already. And so now look what they're doing. They want us to use substitution property. So instead of, they're saying take out this measure of angle 2, and now I should replace that with measure of angle 3. Okay, so we had to do that so we could subtract equal things from both sides. Even though 2 and 3 are interchangeable, I need to plug that, show that I have the measure of angle 3 on both sides of the equation. So now I have the same thing and I can use that subtraction property. All right, so there's an angle proof. We have another one to the right there. This one's talking about bisects, and I know we've talked bisects before, but what does that mean? Remember, bisect means it cuts in half. So what do we know then about this diagram? So that means if BD bisects this angle, then angle 1 has to be congruent to angle 2, because that's what bisect means. So we're definitely going to be doing the definition of an angle bisector. All right, and we're trying to prove that ABC, that's the big angle, ABC, is twice as big, 2 times as big as just the measure of angle 1. All right, so let's do this. We have our given that BD bisects angle ABC, and we just said that the definition of an angle bisector told us that angle 1 is congruent to angle 2. And notice what our next reason is. We have to use the definition of congruent angles. So we're just switching from congruent to equals. Okay, so now we're going to show that the measure of angle 1 plus the measure of angle 2 equals that big angle. Anytime we're doing 2 smaller angles to equal the bigger one, that's called angle addition postulate. And then we have the substitution property of equality. So what are we going to be substituting for? So I'm taking out the measure of angle 2, and what should I replace it with? Well, the only thing the measure of angle 2 is equal to is the measure of angle 1. So we're going to put the measure of angle 1 right here. So it takes 2 angle 1s to equal the big angle ABC. And so this one is kind of a stretch for the distributive property, but basically we're going to say 2 times the measure of angle 1, because measure of angle 1 plus measure of angle 1 is just 2 times the measure of angle 1. And that's how we showed that it takes 2, that ABC is twice as big as the measure of angle 1. All right. So then we've got 2 last proofs. Again, I want you to try this one on your own. All right, there are 2, so again, use whatever form you want. I'm going to display the results as a 2-column proof, and then you can check. So pause the video now, and then do those proofs, and then check them when you're done. Okay, so for this proof, you should have started with some given statements. I chose to just do 2 at a time, because we're just using the transitive property twice. So I chose these first 2, and that angle 2 is what's repeated. So that's how I got to angle 1 is congruent to angle 3. And then I chose to write my other given that I hadn't written before, and the angle 3 now is what's repeated. So then I was able to show that angle 1 is congruent to angle 4. Both of my transitive properties are properties of congruence, and make sure you do POC. All right, so I'm going to pause again, and you do the next one. Okay, so you should start with your given. I started with just those congruent statements, and then I used the transitive property of congruence to state that 1 is congruent to 4. Then I made the switch to equal, so I changed angle 1 is congruent to angle 4 to the measure of angle 1 equals the measure of angle 4. Then from there, I used the other part of my given, and then I was able to do substitution, or you can call that transitive. Either one is fine. And then again, depending, I don't think this last one is necessary, but it's optional if you want to make sure that it looks exactly like the proof statement where the measure of angle 4 is on the left-hand side. So there you go, guys. We did tons of proofs with segments and angles. And now you're going to have a worksheet to work on for homework. And do the best you can. Again, make question marks by any notes and homework that you had trouble on, and I will answer that next class. Thank you.